All right. So what is the rational zero test? All this stuff is going to help you graphing polynomials, which is what we've been working on, right? We talked about the long run behavior and short run behavior, right? Short run was multiplicity, long run was as x approaches negative infinity, it approaches negative or positive, right? Okay, so all this stuff is still building on that, okay? So the rational zero test says, if the polynomial function f of x has integer coefficients, then any rational zero of f will be of the form p divided by q, where p is a factor. How do you find factors? Factors are numbers that add, subtract, multiply, divide. What are factors?
If you multiply, do FOIL or the box method, they do need all them.
Yeah, factors. So what are the factors of 8?
8, 1.
Yeah, 1 times 8, 2 times 4, so multiplication, okay? So it's saying where p divided by q, and p is a factor of the constant, and q is a factor of the leading coefficient. So you still want it to be in descending order, okay? So p is a factor of the constant. The constant comes where? First or last?
Last.
Last. And the leading coefficient is
The first number.
first. So this number is going to help me find my factors of p, and this number, this number is going to help me find my q, okay? So what are the factors of 6?
2, 3, 1, 6.
Yeah, and I always put the biggest first, so, and it's plus or minus always, okay? So it's plus or minus 6. And then I'm going to put plus or minus 1 back here because 6 times 1, and then plus or minus 3 times plus or minus 2. Okay? So if you see, everybody has the counterpart, 6 times 1, 3 times 2. And first block was like, why do you put the plus or minus? Well, positive 6 times negative 1 will give me negative 6, right? Or negative 6 times positive 1. Same thing for the 2 and 3. Okay? So then what are your factors for q?
1.
Yep, just plus or minus 1. So then your possible zeros, you realize this is how you can find zeros. Your possible zeros are p over q. So plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1. You see I literally did 6 divided by 1, 3 divided by 1, 2 divided by 1, and 1 divided by 1. Okay? So all of these numbers could be zeros of this cubic trinomial. Okay? All right, so see about this one. See if you can do it. And I always put it largest to smallest. It doesn't matter technically as long as all of your answers are there. Okay? You get plus or minus 3 and plus or minus 1 for your p's, and plus or minus 2, plus or minus 1 for your q. So then p over q would be plus or minus 3, plus or minus, so 3 over 1 is 3, 3 over 2 is 1.5, right? Which is 3 halves. And then plus or minus 1, plus or minus 1 half. Is that what you got?
Yep.
You good? Yes. All right. So those are possible zeros. So something else that's going to help us find zeros is called Descartes' rule of sign. This is Descartes, not Descartes. Okay? Descartes. So Descartes' rule of sign says the number of positive real zeros of f is either equal to the number of changes in sign of f of x or less than that number by an even integer. Remember the other day we just subtracted 2 from it, the sign changes? Remember that? So that's an even integer, so minus 2 to get to the next one, minus 2 to get to the next one, till you get to 1 or 0. So look, the number of positive real zeros is either equal to the number of changes in sign. So you want to look at the changes of sign of f of x. That means goes from positive to negative or negative to positive, okay? It's not a sign change if you go from positive to positive or negative to negative, all right? Now, the number of negative real zeros of f is either equal to the number of changes in sign of f of negative x or less than that number by an even integer. So to figure out the positive real zeros, you just count the sign changes of the original function. To find the negative real zeros, you substitute in negative x. You see that? And then you count the sign changes. So describe the possible real zeros of f of x equals 2x cubed minus x squared plus x plus 4. Is it in descending order?
Yeah.
Okay, so my positive real zeros. I look at the sign changes of the original function. So from here, what's the sign of this first one?
Positive.
And then this is negative, so that's a sign change. And then I went from negative to positive. Is that a sign change? Yes, and then positive to positive. So I can have 2 because there's 2 sign changes, or 2 minus 2 is 0. So I can have 2 or none. So if you find 1, automatically there's going to be another, okay? That's what that means. Now for negative real zeros, I'm going to, over here to the side, do f of negative x, and I'm going to substitute in negative x. So 2 times quantity negative x cubed minus quantity negative x squared plus negative x plus 4. And then I simplify. What is negative x cubed? Negative x cubed times 2 would be negative 2x cubed, right? And then negative x squared? Yes, positive x squared, but then there's a negative out here, so it's just going to stay negative x squared, right? And then plus the negative is just minus 4. So now count your sign changes. Negative to negative, negative to negative, negative to positive. So there's 1 real zero, negative real zero rather. Any questions on that? No? And just a reminder, because your midterm's in like a little over a month. Yeah, it's the third 6 weeks. So, you know, the midterm's cumulative. So when before did we plug in negative x? Good, even odd or neither. Very good. Good. In this case, it helps us find our negative real zeros. So plugging in negative x is super helpful. Okay? All right, no questions? So for the next 3 examples, we're going to find the real zeros of the polynomial function. We will use the rational root theorem. That's the P over Q thing. Okay, that's called the rational root theorem. And Descartes' rule of signs to narrow down the number of choices. Hint, and this is super important. Hint, remember to use the depressed polynomial once you find the first 0 so that you can eventually have a quadratic polynomial to solve. Depress means once you find the remainder of 0, you've depressed that polynomial. You've made it smaller, okay? Whereas expand means you made it. So once you find a 0 that works, use that new polynomial. And then if you find another one that works, use that new one until you get it down to a quadratic, okay? All right, so we're going to first do Descartes' rule of signs to find the positive real zeros and negative real zeros. All right, so positive real zeros. Here, positive to negative, so that is a sign change. Negative to negative, negative to negative, negative to negative, negative to positive. So we have 2 or 0. You subtract 2 until you get to 1 or 0, okay? So now I'm going to do, and make sure you write this down, p of negative x, so 2 times negative x to the 5th, minus negative x to the 4th, minus 12 times negative x cubed, minus 8 times negative x squared, minus 5 times negative x. I'm running out of room. Hang on a second. Five times negative x plus 6. All right. When you have a negative being raised to an odd exponent, what do you get? A negative. And when you have an even exponent, a negative to an even is positive. So this is going to become negative 2x to the 5th, right? Because it's a negative to an odd. This is going to stay the same, so then bring down the minus, and it's just minus x to the 4th. Negative x cubed is negative. Negative times negative is positive 12x cubed. Do you see what I'm doing? So if it's an odd exponent, what is it doing to the sign out here? Changing it. If it's an even exponent, it's staying the same. So this is going to be minus 8x squared plus 5x plus 6. All right, so how many sign changes? Negative to negative, negative to positive, okay, positive to negative, negative to positive, positive to positive. No, so how many zeros? 3 or 1. Subtract 2 from whatever you get until you get to 1 or 0, okay? So you're definitely going to have a negative real 0. Do you see that? Okay. All right, what should we do now?
Rational root.
Rational root. So P is what? What are the factors of P? First of all, where is P? I did 6, and Q is 2. Okay. So the factors of 6 are 6, 3, 2, and 1. And the factors of Q? Yep. So then P over Q is plus or minus 6, plus or minus 3, plus or minus, right? Because 6 over 1, 6, 6 over 2 is 3. Then 3 over 2, 3 over 1, but I already have the 3 over 1, don't I? So 3 over 2 is just 3 halves. 2 over 2 is 1. 2 over 1 is 2, which is bigger, so I'll put it first. So see what I'm doing? I'm literally taking all these P's and dividing by all the Q's. So I'm on 2. 2 over 2 is 1. 2 over 1 is 2. 1 over 2 is 1/2, and 1 over 1 is 1, but I already have that here. So do I have them all? 6 over 2, do I have it? Do I have 6 over 1? 3 over 2? 3 over 1? 2 over 2? 2 over 1? And 1 over 1? 1 over 2? So they're technically not in order. This is 1 1/2, so it should be behind the 2, but it's fine. The reason I write them in this order, I always start with the smaller ones first and work my way this way, because typically your zeros are smaller. They're kind of closer to the 0 as in the origin, okay? So now we're actually going to start working it now. I know to look for at least 1 real 0. I could have 3. I know I might have 2 real positives or none. Look, what's your exponent? 5. So at most, how many zeros can you have? 5. But they don't all have to be real. Some of them could be imaginary, right? So we just want to look to see if we can find them. So what do you want to plug in first? You want to try to find your negative or your positive? Positive?
No, that's fine.
I know at least one negative will work. That's fine. What do you want to plug in? I normally start down here somewhere. 1?
1/2. Well,
Miranda said 1 first, so it's fine. So 2, we'll try -1 next. 2, -1, -12, -8, -5, and 6. Right? That's my 0 row. Okay? So I bring down the 2 first, then 2 times 1 is -1 plus 2. Remember the other day what I said, the signs are different? Subtract, right? The bigger number minus the smaller, and then keep the sign of the bigger one. So since the 2's bigger, it's positive, this is positive. All right, 1 times 1 is 1. -12 plus 1. -11. -11 times 1 is -11. -8 plus -11. -19 plus 1. Is there any point in keep going? Because look how big it's getting, and you're multiplying by 1 each time. So is that going to give me a 0? All right, I tried 1. You want to try -1?
19, not 18.
Oh, what in the world? Why did I write that? Mm. That's not what I meant to do. Hang on. All right. Oh my gosh! What am I doing?
Well, when you ended it, it comes out negative 10, so. Maybe.
Bless you.
Yeah, because when you add those, you would get -24. And then when you add that to 6, maybe that is why, because you get -18. I don't know. The moral of the story is stop it, Miss Harold. Whew. All right, you want to try -1?
Sure.
Because we're looking for the negative? Sure means you're indifferent,
Yes.
which means you don't really care. All right, so this is a 2. 2 times -1 is -2. -1 plus -2 is -3 times -1. -12 plus 3. -9.
Why did you put the 2 as positive and then negative? Oh, never mind, I see why. That's the other question.
Yeah, that wasn't a dumb question. It's okay. You're good though now?
Yeah.
All right, -8 plus 9. 1 times -1. -1, -6. -6 times -1. Ah! Look what happened. We were so close. So, what we just discovered, neither of those works. If you put an X over it, lightly cross it out. If I can't read it at all, it's pointless. So lightly cross it out. -1. Ah, I crossed it out at the wrong spot. None of you said anything. Why am I up there with the P's? Where am I supposed to be?
Oh,
Now we get Q.
Down here with the P over Q. So I'm gonna cross out lightly this one. All right, so Greg, you wanna try the 1/2? Is that what you're saying?
Yeah, I wanted to do 2.
Are you avoiding it? You just want to do 2? Okay. Positive or negative, Greg?
I want to start with 5.
You want to start with positive, okay? So plug in 2 and bring your 0 row, which was, shh, stop talking. 2, -1, -12, -8, -5, and 6. We haven't found any that work yet, so we're gonna have to keep using that until we do, okay? So bring down the 2. 2 times 2 is, and -1 plus 4, 2. And -12 plus 6? -6. And -6 times 2?
Yeah, you can stop.
-12 and -8 plus -12?
Negative 20.
And -20 times 2?
I feel like they're gonna be one of those fractions.
No, it's
Hey, if you try 2, might as well try -2 though.
yeah.
You know, that way you know that you've tried all, like, if I pick one, I normally do the positive and negative just so that I, yeah. Yeah, -45 times 2 is -90.
Yeah, I feel like it's gonna be one of those fractions just because we don't wanna do them.
Y'all are the ones that don't want to do the fractions. I'm fine with fractions. Fractions are my friend.
After you're talking
P.S. You might want to get a piece of paper. Stop talking. Get a piece of notebook paper because this problem's going to take a bit. I'm not kidding. Notebook paper out. Whining, no.
I'm working on it. Uh-oh. You're-
My head's trying to hurt, so I'm waiting for everybody to get paper and to work this out. Just wait.
Yeah, that's fine.
So -1 and -4 is -5. -5 comes -2. 10 plus -12. -2 comes -2. 4, -8, 4. -4. -4 comes -2.
8.
-5 plus 8.
3.
And 3 times -2.
-6 plus, Greg, you were right.
Hey, hey, hey. What does that mean about -2?
It's a 0.
It is a 0. And we just now found a 0. So instead of being a what was this originally? A 5th degree. So this piece right here is now a 4th degree. We want to get it down to a quadratic. So we got to keep going. What would you like to try? We've tried what? -1 and 1 and -2 and 2. You want to try 3? Yes? Caroline votes 3. So
Yes.
now listen. Listen. Once you find one that works, now you get to use that one. Do not go back and start using this one again. Otherwise, you're never going to get a quadratic. Yes, ma'am.
So, if you like get it down, if you know how the crosstalk one won't work at all, right? You can't reuse it.
No, once it doesn't work, it doesn't work.
Wait.
Hey, that was a good question. She said, once you find that one doesn't work, you can't reuse it. No. If it didn't work up there, once you get it down to a 3rd degree, 4th degree, it won't work anyways. So, all right, are we fine at looking at 3?
Yes.
All right. Reading down to 2. 2 times 3 is 6. -5 plus 6, 1. 1 times 3 is 3. -2 plus 3 is 1. -1. Look at that.
No, we're down here.
No, right.
I thought that number was something.
I want to do 1/2 next after we do the next.
Well, now we found what?
0.
We found
It's the third. So let me point something out. You found the -0 that worked, right? So you don't need to try any more negatives, do you? Because look at what you wrote. We wrote that there would be 3 or 1. Oh, so should I try more negatives?
Yeah.
Maybe. I found a I found a positive 0 that worked, right?
Yeah.
If 1 works, and I look here, automatically I have to have another one. So do you see how this helps you?
Yeah.
If this had been 1 and you found the 1, then you're done. But you've got 1 or 3, so there could be 2 more. We don't know. So you want to try 1/2? Is that what you said?
Yeah. But do we have to do the -3 too?
No, not necessarily.
Okay.
That's how I do it. So what was my new row? 2, 1, 1, -1. 2, 1, 1, -1. 2, 1, 1, -1. And we're trying 1/2, is that what you said?
Yeah.
Why not? We like fractions. 2 times 1/2. What's half of 2?
1.
You realize when you're multiplying, that's all you're doing. 1 plus 1 is 2. Half of 2 is 1. 1 plus 1 is 2. Half of 2 is 1. Look at that. And now it is a quadratic. And we found another positive 0, right?
Yeah.
So now that it's a quadratic, I'll write it 2x squared plus 2x plus 2. Okay? Then what? Factor out a GCF. So it's 2 times quantity, x squared plus x plus 1. Now, can you factor that? No. If this is a plus, it tells me they're either both positive or both negative, right?
Yeah.
So if this is a plus, it tells me they're both plus. But this, the only factors of 1 are 1 and 1. X plus 1, X plus 1 doesn't give you 1x. So you have to use x equals negative b plus or minus square root b squared minus 4ac all over 2a. I suggest you write it and learn it.
Yeah.
You were supposed to already know it from earlier this year. Yeah, sing it. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, what's a, what's b, and what's c? A is whatever the coefficient is with the x squared term. B is the coefficient with the x term, and C is the constant. So when I plug those in, I get negative 1 plus or minus 1 squared minus 4 times 1 times 1 all over 2 times 1. So negative 1 plus or minus 1 squared is 1. 4 times 1 times 1, negative 4, right? All over 2. What happens? What is the square root of negative 3? Imaginary. So what did you just discover? Do you have 5 real zeros? Really? No, I scrolled it like 4 times, and every time I would go over there to write, it would scroll back down. So I'd go over, scroll it, go to right, scroll back down. That's why I said really. I'm not talking to y'all. No, you're good. Do not leave the negative under there. What do we bring out? So you found that you have 3 real zeros, right? And 2 imaginary. So the real zeros are negative 2, 1/2, and 3. So what would those be as factors? X plus 2,
2x minus
2x minus 1. Whatever's in your denominator, see the 2? It goes with the x, and since this is positive, it has to be a minus, right? And then the last one, x minus 3. Now here's what I want to ask you. These are the real zeros, right? If you were to FOIL this out, or box method, whatever, would you get the original function back? No, this would be 2x cubed. Because you don't have these imaginaries here, right? So your factor for the imaginaries is this. So I need to write it. X squared plus x plus 1. These are my factors, y'all. And yes, you have to have all of them. No, we don't use the 2. And you want to know why? It's going to mess it up. Look, this 2, if you rewrote it and you have a 2 here, if you were to pull it all out, you would get 2x to the 5th right now. So if you bring this 2 down, you get 4x to the 5th. And we don't have a 4x, do we? Just 2x to the 5th. So you don't need that 2 because it's already taken in. The real 0 already got it. This 2x right here, okay? That is why I had a mistake on what I sent you the other day. I did that, Miranda. I put the 2 with the answers. Do you remember the third one for the context review? Did any of you notice? You're confused? What? On the homework, you mean? I'm sorry. That I don't know why I was doing that. And then I didn't do it on the homework answers that I gave Mr. Pace. The one that was wound up 6x minus 42. What?
My homework, a few of them I had the thing in front.
Did you?
Yeah.
Somebody emailed me about it, and I got the email coming back on Monday, and that student had gone to see Miss Callie because I wasn't here, and they wanted to make sure, because they didn't get the 2 in their answer. So email me, y'all, email me. That way I can say, oh no, I'm sorry, you know. Which when I was in the other country, it didn't matter. That was a joke. All right. Are you good? I was in the country, but my phone messed up. It said I was out of the country and did I want to allow access and be charged for international data or deny access. And I was in West Virginia.
International data.
Sorry. No. All right. Are you ready? So how can we narrow down our choices even further? I will tell you this. Y'all picked some good numbers. First block, we tried 1, 2, 3, 4, 5, 6, 7, 8 before they got it down to a quadratic. Y'all got lucky. I will tell you this. Don't avoid the fractions because you won't always get lucky. Don't avoid them. Okay. All right. So if you want to narrow down your choices so you don't have to plug all of them in, find the upper and lower bounds of the zeros of the function. The upper bound is the smallest non-negative. What's non-negative mean? Okay, so the smallest positive value of x that produces a row of positive numbers. We've done that the other day. Now, write this down. 0 can be whatever you need it to be. 0 can be whatever you need it to be. Because 0 is neither positive nor negative. It's directly in between the two. It separates positive and negative values. So it can be whatever you need it to, okay? So if all the other numbers are positive and you've got a 0, then just say it's a positive and you got a row of positives, okay? Or if you've got alternating signs except for that one and you need it to be a negative, then it is. 0 can be whatever you need it to be, okay? So then that's the upper bound. The upper bound, meaning no 0 is going to be bigger than that because you get a row of positives, okay? The lower bound is the non-positive. What's non-positive?
Negative.
Okay. So it's the negative x that produces a row of numbers which alternate in sign, meaning plus, minus, plus, or minus, plus, minus, plus, okay? We talked about that the other day when we did the intermediate value theorem. Do you remember?
Yeah.
All right, so here's this example. 3x cubed plus 4x squared minus 7x plus 2 is a cubic function, okay? And it is in descending order, isn't it?
Yeah.
All right. So what we do is we pick, and we try to find an upper bound by picking the integers close to 0, okay? So 1, and then 2, and then 3, until you find the upper bound. So I'm going to show you over here where this row comes from, all right? So I'm going to plug 1 in, bring the 3 down. 3 times 1 is 3. 4 plus 3 is 7 times 1 is negative 7 plus 7. 0 times 1, and 2 plus 0. Did you see how I kept going even though I got a 0?
Yeah.
It doesn't matter, just put the 0 there and keep going. You can get 0 sometimes, okay? So this row is what I'm going to bring over. 3, 7, 0, 2. So now I look. All of these numbers are positive because I can make 0 positive. So what did I just discover? The upper bound. Now, how's that going to help me? Well, can you find the possible rational zeros for this? How do we do that?
Plug them into that, formula thing. So
Yeah, P, Q, and then P over Q. Yep. Move to the other side of the room then. Yeah, that's the solution. That side's always colder because of vents. Look up.
I think it's hot over here.
It is hot over here because we don't have any vents on our side.
Why should they do it like that?
Why do they design it like that? I don't know. If you see the architect, that's that person.
That's like weird though. Like,
I got nothing for you. All right, are we done having a score moment? So this is the upper bound. So what are my P's? Plus or minus 2, plus or minus 1. And the Q's?
3.
3 and 1. So P over Q, 2, 1, 2/3, and 1/3.
What about 3? I don't know.
No 3, because, yeah, this is P, this is Q, remember? It's backwards from what you would think. I know that. I don't know why. So it's just how it is. I don't know. P is the constant, okay? All right, so look what you just discovered. 1, when you substitute using synthetic substitution, you get that it's the upper bound. That means, is 1 a 0? No. Should you even try 2? No, because 1's the upper bound. So do you see how that helps me? I can figure out how many positive real zeros I have and how many negative, can't I? So how many positive real zeros? Look for your sign changes. Positive, 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 negative. So there's 1. There's 2. So I could have 2 or 0. Well, it's not going to be 1, and it's not going to be 2. So it could be 2/3 or 1/3, or maybe both, because I could have 2, right? Okay. And how about negative real zeros? How do I find that?
Negative X.
Yeah, so over here I'm going to put f of negative x. What did we say a while ago? If it's an odd exponent, what does it do to the sign? It changes it, so it's going to be negative 3x cubed. And what if it's an even exponent? So plus 4x squared, it stays the same. And then negative 7 times negative x. So an odd exponent changes it, and then plus 2. So then how many sign changes? 1. So you have 1 negative real zero. So if I have a negative real zero, I need to find my lower bound to make sure to see if I should plug in -2, what should I try using, okay? So you pick numbers close to 0. What's an integer close to 0 but a negative? -1. All right, and I'm not going to make this synthetic division chart every time. I just want you to see where that row came from, okay? So the first thing is always bring down the first one, 3. Do you remember how to do this? 3 times -1? -3 plus 4. 1. -3 plus 4 is 1. 1 times -1. And -1 plus -7. And -8 times -1. And 8 plus 2. So I want you to look. Is that the lower bound? No, because it's positive, positive, negative. It doesn't alternate sign. So now I'm going to try -2. Because that's the next integer. Bring down the 3. 3 times -2? -6 plus 4? -2 times -2? 4 plus -7? -3 times -2? And 6 plus 2? 8. Well, man, does that help me? Let's try one more, -3. -3 times 3? -9 plus 4? -5. -5 times -3? Positive 15. 15 plus -7?
Positive 8.
Positive 8. 8 times -3? -24 plus 2? What did you discover?
This is the lower bound.
This is the lower bound. It better be. Why am I saying that? Look at your P over Q's. -2 is the smallest one, isn't it?
Yeah.
So could it, the lower bound would have to be -3, wouldn't it?
Yep.
Listen, the reason why I showed you this, sometimes you have P over Q, you have like 14 of these. You don't want to try them all, right? So find your upper and lower bound and try the values in between, okay? Because what if this had a plus or -6? Then I would know not to try it because my lower bound's -3, okay? Now, one more thing before we move on for this problem. And yes, you're going to solve it. So if you don't have room, just put it on the notebook paper with the other. But pay attention. Normally, this last thing is called our remainder, right? But that's when we are doing division. Like we're actually dividing a polynomial. Are we dividing a polynomial right here? No. So this last number is actually, if you had substituted in this value. So this last number is actually f of 1. Look at what you would get if you plug 1 in. 1 cubed is 1 times 3.
3.
So that would be 3 plus 4, right? Because 1 squared is 1 times 4. You see what I'm saying? 3 plus 4 is 7. 7 minus 7 is plus 2. 2. So this last number right here, this 10, is what I would get if I plugged in f of negative 1. And wasn't that easier than actually plugging in negative 1? I'm showing you this because sometimes you don't get to have a calculator when you take standardized tests, like for colleges and things like that. So if it said find f of negative 3, it's easier to do it that way and get the last box, the last spot. F of negative 3 is negative 22. Whereas if I had plugged in negative 3 cubed is negative 27 times 3. You see what I'm saying? It's already getting really big, right? So this is really helpful. Remember it, okay? All right, we had our P's and Q's. We know not to try 1 because it didn't work, right? Negative 1 because it didn't work. So I'm going to lightly cross that out. And then we tried negative 2 and it didn't work. And why am I not going to try positive 2? My upper bound is 1. So look how many choices I have now. Well, plus or minus, so technically 4 choices. And look at what I definitely have to have. 1 negative real, 2 or none. Now, some people are like, ooh, I'll try negative 1/3 and negative 2/3. But neither one of those technically have to work for the negative real. Couldn't I get a non-rational, so an irrational 0 that's negative? Yeah, that's just the rational roots, okay? So just keep that in mind. So what do you want to try? 2/3, negative 2/3, 1/3, negative 1/3. 1/3, okay. And my 0 row is 3, 4, negative 7, and 2. Bring down the 3. 3 times a third.
3.
Over 3. 3, y'all need to work some scratch paper. 3 times 1/3 is just 1. Those cancel out, y'all. All right, 4 plus 1. 5 times the third. 5/3. So what do you need to do with the negative 7 and the 5/3? No, you don't cross multiply. Common denominator of 3. So this is actually negative 21 over 3 plus 5 over 3, which is negative 16/3. Negative 16/3 times 1/3. Negative 16/9. Is that going to add to give me 0? No. So why torture myself and keep going, right? Okay, so we now know 1/3 won't work. Want to try 2/3? Did you say negative?
Yeah.
Why? Because you don't like the fraction? Come on, make peace with it. Was he saying negative that he wanted to try negative? Greg, what did you mean? Did you mean negative, like no, I don't want to, or did you mean negative, let's try negative 1/3? Oh, I'm sorry.
Where's Savannah's probably gonna wonder what's going on.
She knows what's up in this class. It's whatever. All right, 3 times 2/3. 3 times 2/3.
2.
4 plus 2? 6. So 6 times 2/3. Yeah, this reduces, doesn't it? 2 times 2 is 4. Y'all need to work some fraction magic. All right, negative 7 plus 4?
Negative 3.
And what do we say? Negative 3 times 2/3?
Negative 2.
I don't know what it is. It's been happening all day, okay? I don't know.
It sounds like an alarm.
And 2 plus -2? Hey! Life is good.
Yeah.
So we started as a what? What kind of function we start at?
Cubic.
A cubic. So this is a,
Quadratic.
hey, life is good. So I get 3x squared plus 6x minus 3. Yep, good. A GCF of 3, so I'm left with x squared plus 2x minus 1. Can you factor it? What times what will give me -1, but add to give me +2? 1 times -1 is -1, but when I add it, it gives me 0. You can't, so what do you have to do? Yeah, you tell me what it is, because I know quadratic formulas.
Negative b plus or minus. Or a divided by 2.
Do you hear what you need to work on? Yeah, I can hear it.
This, they can have that.
So I have a question. If your B is already negative, you wouldn't change it to a positive.
No, yes, you would.
You would.
If your B is negative, then it would be negative, negative, whatever. So yeah, it would become positive.
Okay.
You literally just plug it in.
Okay.
You should be finishing this problem. All right, what are the zeros and what are the factors? Write it. Actually, let's plug into this and see if you got it right. So negative and then 2 is B, so 2 plus or minus the square root of 2 squared. And I always put that in parentheses because if it's negative, negative 2 squared would be positive. So put it in parentheses. Minus 4 times 1 times negative 1. All over 2 times 1. So that becomes negative 2 plus or minus the square root of 4 plus 4. Yep, all over 2. Them signs will get you. Negative 4 times negative 1. Do you see that? Negative 4 times negative 1. It's positive. So 4 plus 4 is 8. Do you leave it like that? No. The square root of 8 can be simplified, can't it? So we get negative 2 plus or minus the square root of 8 over 2. So over on my scratch paper, the square root of 8 is 4 and 2. And then this is 2 and 2. Y'all circle it. I saw it on the FRQ. So it becomes negative 2 plus or minus 2 square root of 2 all over 2. Can you simplify?
Yes.
You look at the numerator. Can you factor? Factor out a 2, and you're left with -1 plus or minus 1 square root of 2, right? All over 2. So it's actually -1 plus or minus the square root of 2. So how many zeros do you have?
2 and that thing.
3. 2 positive and 1 negative. You see it? These are just irrational. Right? The P over Q is your rational roots. These are irrational. So your zeros then would be
2/3. 3x minus 3.
I always put -1 minus the square root of 2. I'll put the smallest first, because that's what you would see graphing. And then -1 plus the square root of 2. Wouldn't that be smaller than 2/3? This is about 0.67. This would be -1 plus 1.414, which is just 414. Okay, so what are your factors then?
3x minus 2.
Just kidding, yeah. 3x minus 2, sorry, yep, and? Very good. Nicely done. Any questions? You're probably going to want a sheet of paper for the next one. I don't know, you might be able to put it on there, but if you write bigger, probably not, so just FYI. Any questions on this one? All right, be reading this one. I'm going to start a new video so this doesn't last forever.